Welcome to today's presentation, Fan Coils 101. Your presenter is Sean White. Sean is the Application Engineering Manager at Titus. He has been presenting for over 20 years and is one of Titus's primary instructors for in-house, online, and on-site technical seminars and lunch and learn lectures. Today's presentation is pre-recorded. We encourage you to submit questions by typing them into the chat questions box. Sean will answer them during the Q&A session after the presentation has concluded. There is a copy of this presentation under Handouts, and you're welcome to download it for your files. This presentation is eligible for 1 PDH credit, and certificates will be distributed by the end of the week. Now let's begin the webinar.
Good day. My name is Sean White, and I am the Fan Coil Application Engineering Manager for Titus. Today we will be discussing fan coil basics. This presentation is intended for an audience that has recently been introduced to the HVAC industry and does not have prior knowledge to the heating and cooling systems utilizing fan coils. We will begin with discussing the fan coil equipment on a basic component level and then move on to how they function. We will go over the major components of a fan coil unit and how they interact with each other to form a complete unit. We will spend time discussing the heart of a fan coil unit and its importance, which is the heating-cooling coil. From there, we will expand to the more common types and shapes of fan coils. We will review several typical installations seen in different types of buildings and applications. Lastly, we will discuss resources Titus has available to you to assist in understanding and selecting fan coil units. So let's start off with discussing what is a fan coil unit in the overall sense. It is a cooling and heating indoor HVAC type of equipment. They are meant for indoor use only in or above the space they serve. At the most basic level, a fan coil unit consists of a fan coupled with a motor and then 1 or 2 coils. One set of valve components is attached to each water coil as well. In this image, only one supply diffuser is shown, but fan coils can be connected to several diffusers through branching ductwork. Starting at the left side of the image, we can see where the return air comes into the unit from the left and then flows through a filter. The filter helps to free the air of dust and other contaminants floating in the air that would otherwise reduce the air quality. This airflow is being driven by the fan coil blower unit. This blower unit consists of a fan and motor to draw the air through the filter and then drive the air through the water coils. Next, the air then passes through the coil section. In this example, the first coil represents a cold water coil to chill the incoming air. The next component is shown as a hot water coil used to heat the air. From there, the air is forced out of the fan coil unit through the unit discharge air opening shown at the right side of the image. The conditioned air flows through the living or working area and then is returned to the fan coil unit through the return opening to be reconditioned as needed. We can also see 2 sets of valve assemblies which control the flow of water through the water coils depending on whether the unit is in heating or cooling mode. The most common types of water-based fan coils are what is referred to as 2-pipe and 4-pipe fan coil units. One water coil assembly will have 1 pipe that delivers water to the coil and 1 pipe that takes water away. In the image on the left, you can see these 2 pipes pointing to the left with a red cap on each one. The pipe towards the bottom left of the image would be the pipe that delivers water to the coil and is also referred to as the supply pipe. The pipe pointing to the left at the upper left corner of the image with the red cap is the pipe that takes water away from the coil and is also referred to as the return pipe. These 2 pipes are what gives the water coil its name of 2-pipe. In the right image, we can see that this fan coil unit has two water coils shown, with a red coil at the discharge opening of the unit and a blue coil behind the red coil. Because the unit contains two water coils, there will be two supply pipes, one for each coil, and two return pipes, also one for each coil. Two pipes can be seen coming off the left side of the coil and two more pipes coming off the right side. These four pipes give the unit its name of a four-pipe fan coil unit. In short, a two-pipe fan coil unit has one water coil inside of it, and a four-pipe fan coil unit has two water coils inside of it. A two-pipe fan coil unit can have hot or cold water inside of it, but not at the same time. Since a four-pipe fan coil unit has two water coils, it can have both hot and cold water inside of it at the same time. Let's discuss now the general applications of where we would find fan coils typically installed. From the list, we can see that the areas a fan coil would be installed into are generally smaller areas. 1 to 3 areas or rooms will typically be serviced by one fan coil unit. Fan coil units are very versatile in that they can be mounted above the ceiling, hanging from the ceiling, behind a wall, or on the ground in front of a wall. Corridors and entranceways are also popular locations like we might see in a dormitory or hotel. Now that we understand a bit about the basic components that make up a fan coil unit, let's move on to the different fan coil families and types. Here we can see a very common array of fan coil types used in many different applications. We can see that the units vary greatly in size, shape, and color. There are very large units like the vertical stack unit on the far right, down to the fairly small units like the horizontal low-profile unit shown in the bottom right of the slide. Some units are painted, which means they are meant to be seen by a person in the room, while other units are not painted, which means they are meant to be hidden and not seen by people in the conditioned airspace. Here we can see all the different types of individual fan coil models. They are grouped into 3 major categories with 2 subcategories beneath each one. Starting on the left, the first major category are the horizontal fan coils. These units are used when floor space is a premium and the customer does not want to consume valuable floor space with HVAC equipment. Small dorm rooms on college campuses could utilize these units where living space is very limited within each dorm room. The next category is the console-style fan coil units. These units are meant to sit on the floor either up against a wall or behind it. A common location would be up against a wall under a window. There are buildings where using a horizontal fan coil unit is not possible due to the premium space availability or low ceiling height rooms. Placing a fan coil unit on the floor is more practical in those situations and are where these units would be used. The final category would be the vertical fan coil series. These units consist of tall, thin units with small footprints or a heavy-duty unit meant to be installed in a closet. Let's begin with the horizontal fan coils with the low-profile subcategory. These units range in CFM capacity from approximately 200 to 1100 CFM depending on unit size. All the units have a low height dimension to fit in tight spaces. Starting with the top left unit, we can see the concealed low-profile horizontal unit. This unit is meant to be installed above the ceiling in the plenum space away from view. It would be ducted to the room to supply the conditioned air to the space. In the top right corner, we can see the same unit but with a plenum box installed around the motor blower section. This plenum box allows for a filter to be installed as well as ductwork attached directly to the return side of the unit. Moving down to the bottom left of the 4 units, we see the recessed with telescoping panel fan coil unit. This unit is meant to be slid up into the ceiling to the point that the bottom panel is flush with the ceiling. The bottom panel serves as a return panel filter holder, and access panel for servicing. For applications where no part of the unit can be in or above the ceiling, the exposed unit is used. It is completely exposed and hangs from the ceiling. As with the recessed unit, the bottom panels serve as return and access panels. The unit is completely exposed to the living and working space for the occupants, so the entire cabinet is painted. A general rule of thumb is that if the unit is painted, it is meant to be seen and will be in the occupied space. Concealed or hidden units won't be seen by the occupied space persons and therefore not necessary to paint. The second subcategory in the horizontal fan coil unit lineup are the high performance units. You may notice they look very similar to the low profile horizontal units. This is because these units are simply the big brother line of the low profile units. They have very similar models to the low profile units, except they are taller and can reach higher CFMs and external static pressures. There is one notable difference in that the recessed unit is gone and has been replaced with another fully cabineted unit that is not painted. The cabineted non-painted unit shown in the bottom left corner of the screen is meant for exposed applications, but applications where aesthetics is not very important. Warehouses and oil change stores are examples where the HVAC equipment needs to be in a cabinet, but aesthetics is not important. Also an application for this unit is in open ceiling restaurants where all of the ductwork, HVAC equipment, and electrical conduits are exposed. During construction phase of the building and once the equipment is installed, all of the equipment is spray painted one color, usually black. There is no need to paint these exposed units at the manufacturing facility if they will simply be repainted at the project site. Before moving on, I would like to show a typical installation of a concealed low-profile horizontal fan coil unit. Many of you will recognize this installation because it is very popular in dormitories and hotels. Many times the furred down section of a ceiling when you walk into a dorm room or hotel is there to conceal a fan coil unit. Room air is returned to the unit through the bottom of the fur down just in front of the entrance door. The air then passes up into the blower section of the fan coil and then sent through the water coils horizontally through the supply grill and into the occupied space. This is a good installation as it uses little ductwork and does not consume floor space. Here we can see the next major family with its two subcategories. These are the fan coil units that we refer to as console units. They sit on the floor, up against or behind a wall, and are oftentimes found under a window. The two units in the top right corner and one in the bottom left corner of the slide are full height units at 28.75 inches for the TVBA unit, 25.25 inches for the TVBF, and 25 inches for the TVBC unit. These units have similar performances and CFM ranges as the low-profile horizontal units, approximately 200 to 1100 CFM range, but the TVBA and TVBF units, you can see, they are not meant to be ducted like the low-profile horizontal units. The TVBF and the TVBA are meant to free blow conditioned air directly into the occupied space. This free blow functionality goes along with the fact that we can see they are painted units. As discussed earlier, painted units are meant to be seen by the persons in the occupied space. The TVBF is a flat-topped unit while the TVBA has an angled top to it. The TVBA is much more suited for school buildings where younger children are located. The angled top prevents books, backpacks, and other educating items from being placed on top of the unit and blocking the supply air opening. These items tend to slide off the top of the unit when placed there. The TVBF, unfortunately, does have a flat top and can be used improperly as a shelf of sorts, but the advantage it has over the TVBA is it is approximately 3 inches shorter. This flat-top console unit would be better suited in office spaces where adults will be present and should be more mindful of accidentally blocking off the supply air opening. The last full-size unit is the TVBC in the bottom left corner of the screen. Right away we can see it is not painted and therefore not meant to be seen by persons in the occupied space like the TVBF and the TVBA are. It is meant to be installed either behind a wall or in a project site provided console cabinet that would fit around the unit. If this unit is behind a wall, then it must be ducted to the living space to be conditioned. If installed in a console cabinet, then it would discharge through the supply opening in the top of the cabinet. We will see later on an example of a project provided console cabinet around the TVBC. The two units along the bottom right of the screen are the low-profile console units. They are much shorter than the full-height units, coming in at approximately 16 inches tall. These units are relatively very short as compared to the full-height units and fit well beneath tall windows. Unfortunately, in order to get this shortened height feature, unit capacity had to be sacrificed. These units are limited to approximately 600 CFM due to the height restriction. As with the full-size units, these two units have an exposed painted unit and a non-painted version. Again, the painted version would sit on the floor in the occupied space and would be seen. The non-painted version would be behind a wall and ducted to the living space. The first subcategory of the vertical fan coil units is the vertical high output series unit. As with previous unpainted models, this unit is to be concealed away from view, typically in a closet. It is a high capacity unit providing 600 to 2000 CFM. Because of this high CFM output, it is meant only to be ducted and not free blow into the living space. Usually the unit is installed in a closet and ducted up above the ceiling, where duct branches then take the conditioned air to various supply grills. This allows one vertical high output fan coil unit to provide air to several different areas. Because the unit is located on the ground in a closet, it is easier to access and service versus a horizontal high output unit that would be up in the ceiling and a bit more difficult to access. The last subcategory of fan coils are the vertical high-rise series units, also referred to as vertical stack units. They have a small footprint and are fairly tall at 88 inches in height. They are generally placed in a corner location, and the most common installation are to then cover the outside of the unit with sheetrock. We can see a cutaway view in the bottom left corner of the screen, where we can see a standalone unit in the corner partially covered in sheetrock. Also, there is a standalone version that has an outer cabinet that is painted and is meant to be seen in the occupied space. It does not need field-provided wall covering around it. The advantage of using sheetrock around the unit is that the sheetrock can be painted to match the rest of the room's color scheme. A useful installation is to use the primary and secondary combination style of vertical stack units. Two identical vertical stack units are paired up with each other. Both units are independently operated from the other one and would be used to condition two separate rooms. A wall would be built between the two units to separate them into two different rooms. The primary unit is only called that because it is the unit that the water supply and return pipes are attached to. The secondary unit simply taps off the primary unit's plumbing in order to take and return the water necessary to heat and cool the air. The vertical stack unit gets its name in that it is popular in tall, high-rise buildings. The units are quote-unquote stacked on top of each other from floor to floor all the way up the building. A vertical stack unit on one floor can have its plumbing attached to the unit on the floor above it over and over again all the way up the building. This reduces project site plumbing work requirements and overall installation costs. Now that we have discussed the major fan coil families and their subcategories, we will now move on to some common installations of several different fan coil models. Here we can see a low-profile, fully exposed horizontal unit. We can see that it has been hung by ceiling rods, and in this particular project, it is to be supplying conditioned air to a duct system for supplying air to a couple different rooms. A wall or ceiling structure will be installed around the ductwork to hide it from view. The unit itself does not need to be hidden away from view and will be seen in the occupied space once construction is complete. You may recognize this unit as we discussed it earlier. This is the TVBC unit and is a floor-mounted unit meant to be hidden from view. In this project, instead of being hidden behind a wall, it is being installed into a pre-existing cabinet structure and will discharge air vertically into the living space. An access panel will be put in place in front of the unit to hide it from view. The access panel will have a louvered section to allow for return air to come into the unit for conditioning. In these two photos, we can see examples of the low-profile console unit installation. These two projects utilize tall windows and come fairly close to the ground and do not leave enough room for a full-height console unit. In addition, there wasn't space for the unit to be installed behind a project-provided custom cabinet, so the exposed painted-style low-profile units are used as they will be seen in the occupied space. We can also see that the unit on the left has stamped supply louvers while the unit on the right has a discharge grill. On the left, we can see a standalone vertical stack fan coil unit that is meant to be installed behind sheetrock. The unit in this picture has already been put in place in the corner of the room and sheetrock walls installed around it. The installation is still underway, so it can be seen that the unit has not been closed up or the walls painted. Protective shrink wrap around the unit is still visible. The unit on the right is also a standalone vertical stack fan coil unit, but it is not meant to have a sheetrock installed around it. It is an exposed unit that comes with its own cabinet and doesn't need a field installed finishing covering. In this particular project, the unit has been installed in the corner of a maintenance or equipment room and is there to provide cooling. An exposed style vertical stack unit was used to eliminate the need for field installing a covering, but since the unit is in a maintenance or equipment room, it will most likely not be seen by normal building occupants. This is why the plumbing and electrical wiring are exposed as well. Here we show a much nicer set of pictures showing a completed installation of two standalone vertical stack units that have been installed in sheetrock walls. In the left picture, it is a little difficult to see, but in the back right corner of the dining area, we can see the standalone vertical stack unit installed. At the top is a rectangular white supply grill sending conditioned air into the occupied space. Below that is the unit's thermostat, and below that a white access return panel. This panel is louvered to allow return air to enter the unit through a filter. Also, all maintenance and servicing of the unit is done through this panel. To the right, we can see another standalone vertical stack unit installed in an arch pillar at the right of the picture. Same type of unit as in the left picture, but a better head-on angle for a clearer view of the installation. The subject of painted and non-painted units has come up several times, so we would like to take a few minutes to go over the paint itself used on fan coils. Generally, the painted cabinet fan coil units will be seen by the occupants of the space and are in the living area. This means that not only can they be seen, they can be touched. Being touched also means being scratched, exposed to falling objects or soccer balls, and other items running into the units. Because of this, a normal liquid paint that you might see on a ceiling diffuser won't be tough enough to help resist chipping or scratching. Fan coils use powder coat paint, which provides a much thicker and damage-resistant paint coating than liquid paint and is much more suitable to being used on equipment where the equipment could be exposed to damage. Powder coat paint is very similar to the paint you find on your car. The powder coat used on fan coils is not quite as thick or as tough as the paint found on a car, but it is very similar and provides a good strong paint covering that is very durable. Finally, we would like to wrap up by listing people to contact if you have engineering or technical questions regarding fan coils. This is my team consisting of Patrick Ramirez, Clarence Devereaux, and Brandon Rickey. Any one of us would be happy to help with any fan coil question or concern that you might have. I appreciate your time in attending the Fan Coil 101 class, and I hope this training was of great assistance.
Thanks, Sean. Now let's go ahead and start the Q&A session.